Right. Awesome. So we're gonna start out with Jacob Nielsen. So Jacob is gonna go first, and he's gonna talk about using R in Excel. So here's this.
Awesome. So just clip it on somewhere?
Yeah,
or?
we'll try to clip it about there.
Yeah.
I know it's so awkward. Yeah.
Yeah, there we go. Okay, and I'll just
pocket or wherever.
yeah.
Awesome.
Very good. Do I have a clicker or just go right here?
Yeah, I think you arrow.
Arrow. Okay. Okay. You're in the right place. So I'll just stand here, I guess. Okay, so I'm going to be talking about, as Julia mentioned, I'm going to be talking about using R within Excel. It's a topic I think about a lot because in the work that I do, we use a lot of Excel applications and Excel dashboards for both internally and externally to our clients. And as I work with Excel a lot, but also as an enthusiastic R user, I always think when I'm using Excel, man, there's just so many easier ways to do this. It's so many easier ways to get the analysis that I want or the data that I want. Whereas using Excel, it's either really difficult, impossible, or very inconvenient. So that. You can use R's, or say I want to use a ggplot in Excel. All in all, possibilities are endless here. To try to hook up R and Excel together. So I'm going to introduce a tool that I learned about recently called BERT. BERT is the basic Excel and R toolkit. Basically, it's a free plugin for Excel. It's an amazing tool developed by Structured Data. You can download it at this site here. I don't know if the slides are going to be available for others later, but you can follow this link here to download, install, and read the documentation about it. But I don't have a lot of time, obviously, but I'm going to kind of demo some of the things that BERT can do, if you haven't heard of it yet. So one of the awesome things is BERT is just like a
hand it off to someone that doesn't know R to refresh later. Do they need R installed on their machine?
So you need BERT. So BERT is a distribution of R technically. So it will need to be, the add-in will need to be installed on their machine.
Okay.
And then if you're storing functions within the workbook, you need to give them functions for retrieving out of the Excel. Basically.
Okay.
So yeah, that's not so good, but
Okay,
it can be portable if you make it that way, I guess. Yeah.
Thanks. Awesome. Thanks so much. So we can leave that right there.
Oh, yeah, it's not mine, sorry.
Yeah. Awesome. That was super awesome, Jacob. Thank you so much. So we'll start our next lightning talk. So it's just right there.
So, like I said, we'll focus on a map. So one of the problems I had is, and I'll explain this graph for a second, made in ggplot. Each dot represents a 15-day mean, and I'm pretty sure this is mean high temperature for a day. So there's 110 stations. This is just through about 30 years or so. What I found is that it was saying in the mountains, these are elevations of 10 feet, they had a 15-day high mean of 75 degrees in the middle of January. Doesn't make a lot of sense. Say in the summer with 15 degrees in the middle of July, even in the highest parts, they don't get that high in the low. I mean, they don't get that low for the low night temperature. So I had some observation problems. So just to give you the size of the data, everything in these dots outside of these box plots, well, these edge dots I decided to impute was about the outside 0.5% of the data. So how did I go about trying to impute those values? One way you can do it is through a for loop. So each of those bad values had stations around it that on the same day at the same time, or the same 15 days, had good values. So how do you go about estimating that? I thought that we have a threshold. So we look at the stations around in a good data set that have the same day within a certain elevation, within the same distance, so that it captures the certain mountain ranges more or less, what they would have done in those 15 days. So here's just something that I thought you might be able to do with a for loop. I didn't construct this in R, thankfully, but I was thinking for every bad data set row, you go through every good data set row, and then you go through your threshold. It's pretty straightforward. However, the map function is very nice to use, for those of you that might be familiar with it. So the map comes from the package per. Anything that has to do with map or per, all you have to do is think lists. It all works with lists. It's very nice. So I have a list of all the bad temperature observations. All I have to do is through it through my threshold function, and it'll output for me a list of good observations for each of the bad ones. And so this is a nice clean way of doing it. If you have a large amount of data, you can always use the future map, comes from the FIR package, and that does it in parallel. And that's very nice. So here's what it looks like with the map. So I have a function here where there's the good data. I basically just filter out, and here's my thresholds that I set. If you're used to SQL, this is just a where clause, basically. So the X, that's the bad data set observation. So for every bad data set observation, I would look for everything in the good set that was within the thresholds. How do you pass that in? You basically pass in the bad data set, split on every row, and then throw it through the map function. This is very clean. I think it's easier to look at than going through a couple of for loops. And so this is how I went about re-estimating or imputing those bad temperature values. Just to show you guys some of the cool, captivating finds, this is one of the most interesting graphs I saw. So this is the 15-day minimum temperature at certain elevations across about 40 years. You can see that at night, it's not getting as cold as it has before. This is a very interesting graph. I thought maybe the data was bad, but I checked with NOAA, which is the National Oceanic Atmospheric Association. They gave me the same graph and said that they did the same study in finding this, it's not getting cold at night anymore in the mountains. Now, I don't know why, but that's the data. Also, since my original question is how would rising temperature affect snowpack at different elevations, I looked at the snow depth per elevation over the same years, more or less.
So the question was, why did you split the data before applying map?
Right. Just because to pass something through the map function. Are you familiar with the map function at all?
Yes, I use it and I don't split it, so that's why I'm wondering if I'm doing it wrong.
Oh, okay. It's just so I can create a list of values. And so I've never been able to pass really a data set completely through map. I don't think it works that way. So that's why I split on every row to make it a list of rows.
So it's like you're passing a one-row data set and a whole bunch of per the length of the data.
Exactly, because I want a list of good data for all of the one bad data. Just the way I did it. There could be other ways for sure. Yeah. Yes, sir.
What happened in 1970?
So the question is, what happened in 1970?
On the previous chart.
Oh, for this guy?
Yeah.
That is a great question. I didn't have enough time to look through that, but
Different sensors or something?
yeah, they were installing a lot of these sensors, SnowTel sensors back then. Maybe the readings weren't as good. I don't know.
Yeah, nice.
Sir.
Did you look at snowfall as well, like the amount of snowfall?
question is, did you look at snowfall compared to snowpack?
I think that's a great question. I think the data that they only provided me was snowpack. It did have cool things like snow to water ratio. In fact, that's the only reason I was able to back estimate the snowfall, because really the snowfall didn't exist until about 2000. So I had to back estimate about 30 years of values.
Great. So we can catch you if you have any other questions, or Andrew, we can catch you later. So thank you so much. That's awesome.
Thank you, guys.
Great. So our next lightning talk is from Mark Nielsen, and Mark is going to be talking about interpretable machine learning with lime, the lime.
So this is not limes as in the ones you eat, and it's not the limes that you ride down on the street. I think they just have some new bikes now. Saw that. But so lime, what it stands for is local interpretable model agnostic explanations. And my favorite, I guess it's 2 words here, is model agnostic, right? So it doesn't matter if you do random forest, doesn't matter if you do XGBoost, it doesn't matter if you do neural networks, logistic regression. I don't know why you would apply this method for logistic regression, but hey, if you have a kind of black box model, this is the method you use to try and come up with some explanations for specific data points in your data, right? So what are these explanations, right? I put a little visual here to give you just a portion of what is happening within Lime. Basically, the red represents all your data. You want to focus in on one single data point, and then you create a bunch of permutations around this data point using your model, and then you fit a linear model. I mean, these explanations are basically linear approximations of this complex model in that local area, right? So, for example, I go to a physician and say, hey, patient XYZ, well, Billy Bones in this case, is high risk for coronary artery disease. And the doctor's like, okay, I don't see any reason why he should be. Why is he high risk, right? And that's when I go back, I used a gradient boosted machine and I can't get out the coefficients, and right, just like a linear model that physicians are probably used to. But I can still use this method to zoom in on Billy Bones and try and get, it's almost like trying to get a feel for, well, if I take move him a little bit this way, what happens to his probability if I take him and move him this way? Except just instead of doing that 1 or 2 times, you do it like 500 times, right? Or 5,000 times, however many permutations you want to do. And then you fit, there's different methods. The simplest is just fit a ridge regression or regression with L2 norm, right? Penalization. To get the coefficients that most affect that patient, right? His probability of having coronary artery disease, right? So I used an example data set from the Intro to Statistical Learning. I have the link up there. It's predicting coronary artery disease. And once you fit your model, you can fit your Lime model and then produce this explanation plot, right? So if I were to look at importance, model importance using permutation method, right? I might see, for example, I'll just explain. So I might see, for example, some of these look pretty influential on my outcome for each of these individuals, right? So you see chest pain across the board, all that green, or CA, all that pink up at the top, or the max heart rate or old peak. So those variables would show us the ability to
document from each department. And you're working for a big company and you don't know, much about each department in detail. And you're not expert of those domains, and you may want users to model the topic model. And for example, you might want users to change the number of topics that to detect the topics, or maybe the user may wants to describe and label what those topics are. So here's the sample user interface. So you probably wants to create the default model first, and then let user load the model, and then the user can change the number of topics, and then on the right hand side you provide some information about what each topics are, and then user can for example save the label of those topics, and then if user like it they can save changes. Okay, so for this type of application, since the multiple users can interact with your application at the same time, the .r data, the file, probably not a good idea. So you might want to use the database. Okay, and I searched this this issue with a Stack Overflow. And yeah, even so, it took me several days to figure out. So I'd like to share this. It's quite technical, but depending on the database you're using, it might be a little bit different. But I tested this method with the SQL Server 2012, and the data type, the column of the data type, I used the var binary max. It's a Microsoft SQL Server data types, but replacing that max, this portion. So you might want to save your space, and when I specify like 2000, it didn't work for some reason. So you have to specifically have to put max on it. And so suppose the in your web application, you have the R model object, and you call this save model function and pass that model. So this is the R model. And then you're saving that to the database, so you might want to for that model. And then the first you're going to do is the serialize the R model object using this serialize function. And the important thing is the ASCII T. You need it. I'm not sure exactly why, but if you don't put that, it doesn't work. And then you serialize that, and then the return is what is called the row. I'm not sure if it's a data type, but it's called row data type. And then you need to convert that row to character, and then this is your character. So you convert finally your model to character. And then later you're inserting that model to the database, but you're going to create the one row that you're going to put in the database. So this is your model key, and then you're using SQL convert function, and then pass that the sequence. Oh, I'm sorry, it's the character here. So this is the S model, and then you're converting to the binary. Okay, so this is what you want to do, and then this code is creating this record here. So you're pasting strings, but basically you're creating one row of tables, and then you get that one row in value, and then you create the SQL code, insert into your data, insert into your table and value in this tuple. And that, if you execute that, it will insert this. And then the first, your model is character, but you're using this SQL convert function, and then finally convert it to the binary and save it to the database. Now, so once you save the database, you want to retrieve that and then use that model. And this is the get model function. and you pass the model key, and then you just create the SQL statement, select model from your database where key is your key. Okay. And then here, the model, this is the column name, and this is the binary. And you convert that to the character. So you get the character in this data frame. Yeah. And then your data frame column is the model. So this is the data frame, and this is the model character. And then you convert it to row, character to row, and then serialize. And then you got your favorite model object in R. So you can call this. So once you get this, you can use your model function as usual. Okay. Yeah. So just a note. I thought, why don't we just get that model as binary itself, and then some the return seems like character. Even if you don't convert, but somehow this unserialized the model, get missed for some reason. Okay, I think that's it. Okay.
Wow, that's so interesting. That's really interesting. So this is really clever. So this is not like R and SQL. Like it's not like a stored procedure or anything. This is a SQL server that does not have the R installed in it. You know how you can have the R procedures stored. So this is not using any of that. This is just
normal SQL server.
Yeah, that's really interesting and clever. Any questions?
Yes.
Just out of curiosity, when you your first attempt, like the naive thing that you tried first, what did you try and why did it fail? Like what kind of errors were you getting? Like if you just take the characters and just store them, let's say, right?
So the last thing I figured out is okay. So the question is where did I struggle? Okay. So last thing I remember was the database data type. So I was trying to save the space, and then going back here. Yeah. So this is the the table column type, but I was trying to save the space, and then verb binary like 2000. I thought that's enough, but for some reason it didn't work. I just changed the max, and then it started to work. Yeah, and all the so you're changing that to row, and row is not quite binary, and that ASCII T is another point, and they were changing row to character to row, row to character, and then binary to the database. So there's a lot of conversion.
You had the right idea about the conversions. You just had to insert these weird extra parameters and extra little things, and that just fixed it. And it just seems really weird. Those are like really weird errors.
Yeah.
Yeah, that's really interesting. Great. Thank you so much. All right, so we're down to our last of our community lightning talks, which is fabulous. All right, so Kaplan is our last speaker, and so Abby, come on up. We'll get here's the mic for you. And so Abby is